Okay, section 10.3, we're talking about arcs of a circle, and hopefully this won't take too long for you guys. Oh, look, it's a diagram without anything written. Lovely. Okay, so we're starting with this circle, and what we're going to do is talk about the different kinds of arcs that you can find in this circle. So first kind of arc is the arc that we've been dealing with since chapter 9, and that is the minor arc, which is an arc that is less than 180 degrees. So on this diagram, you can see that we have this small arc right here, JK, and that is definitely less than 180 degrees. Actually, it looks like this is perpendicular, so it looks like it might be 90 degrees. Okay, so that would be JK. And you only need 2 letters to name a minor arc. But now, had we started at J and gone all the way around this way to get to K, that's definitely an arc that's more than 180 degrees. And so that's called a major arc. So you have a minor arc and a major arc. And then how do you distinguish? I mean, the 2 endpoints are J and K. They're the same, whether it's the minor arc or the major arc. So the way that you can tell the difference is that in the major arc, you're actually going to use a third letter or a third point. As you're traveling from one endpoint of the arc all the way around, you pass through a point, I in this case, to get to K. And so that's how you know the difference between the major and the minor arcs. So this would be arc JIK as opposed to arc JK. And then the third kind of arc is kind of silly to think of it, but we talk about the semicircle, which is exactly 180 degrees. And that is an arc itself. Okay? All right, so now, congruent arcs. In order to say that 2 arcs are congruent, you have to know more than they have the same measure. You can have, theoretically, you can have 2 arcs that say measure 50 degrees, but they're in completely different circles that are different sizes from each other. Because remember, the measure of an arc is just talking about the number of degrees that are between the 2 chords that are creating the arc. Okay, so it doesn't matter how big or small your circle is, the measure could be the same. So what we also have to tack on here is that they have to be part of the same circle, or they have to be part of congruent circles, which we saw from the last section. Congruent circles have to have congruent radii. So that means that they are the same size. Okay, so that's really important to remember, that congruent arcs have to have the same measure and are part of the same circle or congruent circles. Okay? Now, what I've done for you here is I've taken these 6 theorems and I've combined it all as one to make things a lot easier for us. If you wanted to, you can go look at your book. They have them all laid out, all 6 individually. But pretty much what they're talking about in these 6 theorems is the relationship between the central angles, the chords, and the arcs. And so what we can say is that if you know that you have congruent chords, then you can say your arcs are congruent, or you can say your central angles are congruent. Likewise, if you know the arcs are congruent, you can say that the chords are congruent, or you can say the central angles are congruent. And to finish it off, if you know the central angles are congruent, then you can say the arcs are congruent, or you can say the chords are congruent. So basically, any combination of 2 of the 3 of these going in either direction, that's what the arrows mean in both directions, that you can go either way, holds true. So if we look at our diagram here, so say it was given to us that angle JHK is congruent to angle LHM. So that was given to us. By this theorem, central angles congruent, that implies that the arcs are congruent. It implies this is congruent to that. Or what if I didn't want to do anything about the arcs? Maybe I wanted to say the chords were congruent instead. Well, I could say that. So I would know that these chords are congruent. And the way I would write that in a proof would be congruent central angles imply congruent chords. Or I could have said congruent central angles implies congruent arcs, depending on what I wanted. Okay, and you can go the other way too. So what if, by whatever reason, you know that JK is congruent to LM? then you can say the arcs are congruent, or you could say the angles are congruent. Okay, so you'd be able to say arc JK is congruent to arc LM, or you could say angle JHK is congruent to angle LHM. And you would say congruent chords imply congruent arcs, or you could say congruent chords implies congruent central angles. Okay, so this is a really nice, handy shortcut for when we want to reference these in proofs. Yes, you're going to be doing more proofs. Sorry, we're almost done. Okay, but that's it. That's how short this section is. Okay, pretty nice, right? Enjoy.